CBMC, ece, NMMC, EEE, Unit 3, multiple integrals. Lesson 13. Problem 33. Evaluate integral 0 to 1 integral root over 1 minus x square integral 0 to root over 1 minus x square minus y square 1 by root over 1 minus x square minus y square minus z square dx dy dz. Solution I is equal to integral 0 to 1 to 0 to root over 1 minus x square integral 0 to root over 1 minus x square minus y square 1 by root over 1 minus common minus here xy variables appears, opposite variable is z, so first we integrate with respect to z. Here opposite variable x is appears, opposite variable is y, integrate y, next integrate x. So these are z limits, these are y limits, these are x limits. X limits are x is equal to 0, x is equal to 1. Y limits are y is equal to 0, y is equal to root over 1 minus x square. Z limits are z is equal to 0, z is equal to root over 1 minus x square minus y square. Squaring on both sides. Squaring on both sides. One minus x square minus y square. X square plus y square plus z square is equal to 1. Is a sphere. Center 0 0 0. Radius 1. So use spherical polar coordinates. Using spherical polar coordinates, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta x square plus y square plus z square is equal to r square, dx dy dz is equal to r square sin theta dr d theta d phi dr d theta d phi. Here x starts from 0, y starts from 0, z starts from 0. That represents positive octant. In case of positive octant or limits r is equal to 0, r is equal to radius 1, theta limits r, theta is equal to 0, theta is equal to pi by 2, phi limits r, phi is equal to 0, phi is equal to pi by 2. Usual limits are r limits are equal to 0 to radius, theta limits 0 to pi, phi limits 0 to 2 pi. Actual limits. Actual limits. Actual limits. R is equal to 0, R is equal to radius. Theta is equal to 0, theta is equal to pi. Phi is equal to 0, phi is equal to 2 pi. Actual limits. These are actual limits. Therefore, I is equal to integral 0 to pi by 2, integral 0 to pi by 2, to 0 to 1 by root over 1 minus r square sin theta dr d theta d phi, dr d theta d phi. You write integral 0 to pi by 2, these are phi limits, you write d phi, to 0 to pi by 2, these are theta limits, theta means sin theta d theta, integral 0 to 1 by root over 1 minus r square dr, integral d phi 0 to pi by 2, integral sin theta minus cos theta 0 to pi by 2, integral 0 to 1, you write this 1 minus r square by root over 1 minus r square. You write like this, minus 1 plus 1 cancel, r square we get r square, 1 minus r square by root over 1 minus r square. Here pi by 2 minus 0, upper limit minus lower limit, minus cos pi by 2 0, cos 0 1. Here separate it, integral 0 to 1 by root over 1 minus r square dr, minus integral 0 to 1 minus r square root 1 minus r, root of 1 minus r square dr. Put bracket. This is equal to minus and minus plus 1, so pi by 2 into, here formula sin inverse r 0 to 1. For this formula, root over a square minus r square formula. So x by 2 means r by 2 root over 1 minus r square plus a square by 2, a square means 1 by 2 sin inverse r 0 to 1, pi by 2 sin inverse 1, sin inverse 0 0, sin inverse 1 pi by 2 minus 0. Upper limit minus lower limit. Here upper limit 1 minus 1 0, sin inverse 1 pi by 2, upper limit minus lower limit 0 or 0, sin inverse 0 0, pi by 2. This is pi by 2 minus pi by 4. Pi by 2. Pi by 2 minus pi by 4. Pi by 4. Taking LCM 4, we get pi by 4. So pi square by 8. Problem 34. Problem 34. Evaluate the triple integral xyz dx dy dz over the positive octant of the sphere x square plus y square plus z square is equal to a square. Solution. Clearly given one is sphere, so using spherical polar coordinates, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. X square plus y square plus z square is equal to r square. But here x square plus y square plus z square not given, xyz is given. So xyz is equal to r sin theta cos phi into r sin theta sin phi into r cos theta is equal to r cube sin square theta cos phi sin phi cos theta. Here positive octant. So r limits r is equal to 0, r is equal to radius, here radius is a, r is equal to a. Theta limits r, theta is equal to 0, theta is equal to pi by 2. Phi limits r, phi is equal to 0, phi is equal to pi by 2. Therefore I is equal to integral 0 to pi by 2, integral 0 to pi by 2, integral 0 to a xyz r cube sin square theta cos phi sin phi cos theta. Here dx dy dz is dx dy dz is r square sin theta dr d theta d phi in spherical polar coordinates. So here r square into r square sin theta dr d theta d phi is equal to integral 0 to pi by 2. These are phi limits. Phi cos phi sin phi. So sin phi into cos phi d phi. These are theta limits. Second one theta limits. Sin square theta sin theta. So sin cube theta cos theta d theta 0 to a r cube r square r power 5 dr sin phi derivative cos phi. So this is nothing but sin square phi by 2 0 to pi by 2 sin theta derivative cos theta. This is nothing but sin power of 4 theta by 4 0 to pi by 2 integral r power 5 is r power 6 by 6 0 to a is equal to sin pi by 2 1 square sin 0 0. So sin 1 square 1 by 2 1 power 1 by 4 a power 6 by 6. So a power 6 by 48 a power 6 by 48. Here formula is integral f power nx into its derivative f dash x dx is equal to f power n plus 1 by n plus 1. Using this formula here, sin phi derivative cos phi. So you add 1 to the power n. This is the formula. Power is 1. 1 plus 1. So sin square phi by 2. Here sin theta derivative cos theta. Same formula, use same formula. Add 1 here. Sin for 4 theta by 4. 0 to pi by 2. This is the easy method. Don't use trigonometry formula. Use this formula, shortcut formula. R power 6 by 6. So upper limit sin pi by 2 1 square minus 0 sin 0 0. No, it's not right. 1 by 2. 1 power 4 by 4. 1 by 4. A power 6 by 6. A power 6 by 48. Problem 35. Evaluate triple integral xyz by root over x square plus y square plus z square dx dy dz dx dy dz taken throughout the volume of the sphere x square plus y square plus z square is equal to a square. Solution. So sphere is given. We use spherical polar coordinates. Using spherical polar coordinates, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. X square plus y square plus z square is equal to r square. X, y, z is equal to r cube sin square theta cos theta cos phi sin phi. Observe the above problem. Dx dy dz r square sin theta dr d theta d phi. Here this is not positive or tent. Throughout the volume, you have to write actual limits. R limits r is equal to 0, r is equal to a, radius a. Theta limits r, theta is equal to 0, theta is equal to pi. Phi limits r, phi is equal to 0, phi is equal to 2 pi. Therefore, I is equal to integral 0 to 2 pi, integral 0 to pi, integral 0 to a x y z r square r cube sin square theta cos phi sin phi by root r square r dx dy dz is r square sin theta dr d theta d phi. So this is equal to 0 to 2 pi, phi limits. So sin phi into cos phi d phi 0 to pi, these are theta limits. So sin cube theta cos theta d theta 0 to a r cancel r power 4 dr sin phi derivative cos phi. So sin square phi by 2 0 to 2 pi. Here sin power of 4 theta by 4, same as above model, limits different. Those limits are belongs to positive octant, these limits are belongs to actual diagram, actual throughout the volume of the sphere. So actual limits, this is r power 5 by 5 0 to a sin 2 pi 0 minus sin 0 0 sin pi 0 minus 0 a power 5 by 5. Our answer is 0. By 4 ఎలా రాయాలో అర్థం అదో ప్రాబ్లం ఉంది.